The density of a material can be found by taking its mass and dividing by its volume. Density is important because it's an intensive property. That means it's the same whether you're talking about a little bit of the material or a large amount of that material. All right, so we can use this calculation, density equals mass over volume, in other calculations to find mass if we're given volume and density, or to find volume if you have mass and density. Let's go ahead and figure out how to do this. All right, so density equals mass over volume. If we want to get mass by itself, I'm going to multiply both sides by volume. So the volumes will cancel out on the right-hand side. And so I'll get V times D equals mass, or mass equals density times the volume. If I want to find the volume, but I'm given mass and density, I can go ahead and I can use what I just found, and now I need to get volume by itself. So I'm going to divide both sides by density, and I'm going to get that volume equals mass over density. And now these two equations will allow us, if we are given information on the material, to find either the mass or the volume. So let's use this for an example. Let's say we have a problem where we have 1.2 kilograms of lead, and we're given the density of that lead, and we want to know its volume. So we're going to use this equation here, and it would be tempting just to plug in the mass that we have and the density we have and just do the calculation. But that's not going to work, and it's not going to work because notice one of them is in kilograms and the other is in grams. So we have to do a conversion before we do this. So we're going to convert the 1.2 kilograms to grams. And remember, 1 kilogram equals 1,000 grams. That's going to give us 1,200 grams. Now we're going to use this in there. And because we're using two calculations that both have grams, the grams are going to cancel out, and I'm going to be left with centimeter cubed. So this is going to get me 106.2887511. My units will be centimeter cubed. This is what my calculator spits out. But remember, we have to look at significant figures. So in this case, we have a mass, 1.2. This has two significant figures. And so the density of 11.29, that has four significant figures. So my answer is going to only have two. So what I'm going to do is I'm going to keep the 1. I'm going to keep this 0. And I'm going to round it based on this 6. Because the 6 is greater than 5, I round up. And so this becomes 110 centimeter cubed. My answer has two significant figures, and it's in units of centimeters cubed. Now, a key thing in all these calculations is always to look at the units. Dimensional analysis means that if we do a calculation on the numbers, that calculation is also done on the units. So in this case, we had to get them both to grams, right? 1,200 grams and 11.29 in order for those to cancel out.